Olá pessoal, bem-vindo ao canal de Tecnologias e Ciências. Vamos mostrar para você o que você precisa saber, sem induzir, sem comentários e sem pontos de vista. O futuro é um vislumbre da sua imaginação. Olá pessoal, bem-vindo ao canal Tecnologia e Ciências, e hoje a gente vai apresentar um site de experimentos com a Google, um site de experimentos de inteligência artificial. Esse site, ele mostra, como a gente tem aqui na tela, experimentos com escrita. Então, quando você for entrar nele, ele vai ter um vídeo explicativo de como que funciona e uma view de collections. Vai ter experimentos em leitura de máquina, né? Você tem aqui algum overview sobre os casos e explicações que a gente vai mostrar no vídeo hoje. Tem draw, que é a parte de imagem, também tem um overview a respeito, entre outras, como música, né? E outros experimentos relacionados à identificação de imagem, som, né? e leitura, tá? Como que isso funciona na inteligência artificial? Esse site está explicando. Nós podemos aplicar alguns casos, né, nossos próprios, né? Ele dá essa opção nesse site de experimentos. E vamos lá, vou mostrar para vocês os vídeos que ele esclarece como que isso é feito.
People are training computers and creating machine learning models to explore all kinds of new ideas. New ways to interact.
Yes.
To understand the world. To play. And experiment. But machine learning is pretty intimidating to get into. So we've been wondering, what if it wasn't? With Teachable Machine, we set out to make it easier for anyone to create machine learning models without needing to write any machine learning code. When it first launched in 2017, it allowed everyone to get a feeling for what machine learning is all about. But now, Teachable Machine puts the power of machine learning in your hands, allowing you to save your models and use them in your own projects.
So let's say you want to build a model to recognize you versus your dog. You just open up the site, record samples of you and samples of your dog. Click Train, and you instantly have your own machine learning model, which you can use in your sites, apps, and more. You can upload your model to host it online, or download it to work entirely on device.
With Teachable Machine, you can create custom models for all sorts of things. Using images, audio, or even poses. Personalized machine learning models for the things that matter to you. And folks have already been trying it out, using Teachable Machine in their own experiments, solving problems in their communities, or even just at home. Start creating and see where your ideas take you at g.co.
Hi, I'm Daniel.
Hi, I'm Martin.
Hi, I'm Fernanda. Machine learning is pretty complex, so we've been experimenting with ways to visualize what's happening. There's a core concept in machine learning called high-dimensional space. Here's one way to wrap your head around this concept. You can think about people as being high-dimensional. For example, take famous scientists. You can think about when they were born, where they were born, their fields of study. Each of these is like a dimension of that person. These dimensions become difficult to untangle when you think about different people, because someone might be similar in some ways, but very different in others.
But this is the kind of thing you can use machine learning for. With machine learning, the computer isn't told the meaning of these dimensions, it just sees them as numbers. And it sees each set of numbers as a data point. But by looking across all of these dimensions at once, it's able to place related points closer together in high-dimensional space.
Here's a concrete example where words are treated as high-dimensional data points. The important thing to remember is that we haven't told the computer the meaning of words. Instead, we've shown it millions of sentences as examples of how words get used. Here's a visualization of the results. We're looking at a subset of words that the computer has learned about. Each dot represents one word. Each word is a data point with 200 dimensions. Using a technique called t-SNE, the computer clusters words together that it considers related, and clusters form based on meaning, even though we've never taught it the meaning of words. Here is a cluster of numbers, months of the year, words related to space, people's names, cities, and so on.
We can also look closely at smaller sets of words. If we search piano, we can run t-SNE only on words related to piano. We get clusters of composers, genres, musical instruments, and more.
And this approach doesn't just work for words. For example, you can also treat an image as a high-dimensional data point. Here's a data set where lots of people wrote digits between 0 and 9. People write in all kinds of ways. So the question is, instead of us needing to manually code rules for all the ways people write, could a machine figure it out itself using machine learning? Each image is 784 pixels. The computer treats each pixel as a dimension. Again, using t-SNE, it clusters these images in a high-dimensional space. We've color-coded them so that it's easier for us to see what's going on. And you can see groups of digits clustering together. It's learned something about the meaning of these digits.
These visualization techniques we've been exploring can be useful for all kinds of things. That's why we're working on open sourcing all of this as part of TensorFlow, so that anyone can use these tools to explore their data.
Neural networks, and in particular convolutional neural networks, have been at the heart of many recent research projects with an artistic flavor. Some of the better-known ones have been Deep Dream, a neural algorithm of artistic style or style transfer, deep generator networks, and most recently WaveNets, which learn to generate audio. They've also been found within many practical applications, so everything from self-driving cars to speech-to-text systems and AIs that can play the game of Go. Their recent success comes from an ability to accurately recognize and describe images, but the way they do this remains a mystery to most people. We can get a few intuitions about what's really going on by inspecting them, looking inside them, and seeing how they see the world. What you're looking at is a neural network which is processing my webcam in real time. It scans the image looking for patterns, or what we call features. The patterns look like these. So some are lines or edges or gradients, just really minimal multi-pixel patterns, things like that. And these responses, which we sometimes call feature maps or activations, show us the presence of those features inside of the image. So in the first layer of the network, we've discovered edges, gradients, and patterns like that. Things get a little more interesting when we repeat this process many times through a sequence of layers. At each layer of the network, we take the feature maps from the previous layer, stack them together into a new volume of data, and do another round of convolution on top of them. So the activation maps in the second layer, which we're looking at here, are more interesting because rather than looking for patterns from the raw pixels of the original image, we're now looking for patterns from the activation maps of the previous layer of the network. So for example, it might be able to combine vertical edges and horizontal edges to detect corners, which we can think of as higher level features. As we do this process many times, progressing through every layer of the network, we acquire higher and higher level features or representations of the image. So we go from things like edges and gradients to corners and grids to yet progressively more complex features, maybe things like leaves or fences or door handles, to yet even higher level features, houses, cars, people, and so on. This process of pushing data through the network over many layers of transformations is why these algorithms are sometimes called deep neural networks or deep learning. The deep just means the network has many layers. When we finally arrive at the last layer of the network, we have this compact representation of the content inside of the image. And we can attach one more classification layer on top of that so that we can describe accurately what's inside the image. So for example, if I place my phone in front of the camera, it'll go iPod. Or if I place this water bottle in front of the camera, it'll accurately detect the water bottle. Now, it can be a bit hard to understand what the feature detectors are looking for, but it turns out that there are ways, and there has been some work done in the past. Some of the first work came from Rob Zeiler and Matt Fergus in 2013, where they showed patches of actual images which cause certain feature detectors to light up. Another nice resource is Deep Visualization Toolbox, which was made by Jason Yosinski et al. And was a major inspiration for the visualization software that you saw in the last slide.
Of revelation.
I love this story, and then it's like a roller coaster. It's like a big dip, and I'm like, oh, I hate this.
The first time I ever started to write was on an iPad.
The Google Creative Labs introduced us to machine learning tools that are trained on sets of data, a corpus. I know that word. You import the prompt, and it uses what it knows from the data that it's been trained on to spit out a coherent response.
I used the ML tools to navigate my own authority over my writing. How much do I know about my character, but how much could someone else know about the character?
There's one where you can talk to a character, which I find really useful. It spat out this line that was like, I have broken water over too many people who didn't deserve it. That's, oh, breaking water. Is that like crying? Is that like raining? Like what? It set me off on this whole thing. My sister accused me of cutting off my snakes to spite my head. So I cut off my own head to spite her.
The woman sitting beside the sensible man has lost her eyelids. Her eyes are completely circled.
I was able to get a whole outline of a story that I wanted just by chatting. She thinks that I don't love myself enough, that I'm carting my head around just for attention.
It made me aware of how randomness affects my work. I thought I was a very methodical writer, and by using these tools, I was forced to realize that I could actually harness noise. When I consider the relation between myself and a memory of myself, it's differences that I obsess over.
This was a lot more about process, having an element of play in the actual construction of the writing. And it really got me out of my head a lot.
I feel so trapped by my thoughts and my patterns of thinking. And these tools, they spit out some random nonsense that is strange, and these sentence constructions that are so novel.
I think in the future I would use it to question a stagnant piece of work. ML tools is a good middle ground. There is like what you look to for influence and inspiration and information. And then there's you and like your subconscious as a writer. And then I think it sits really nicely in between that. Her face has lost some texture. She is frozen.
What I meant to say, at least today, is I'm sorry and I cannot live inside the past forever.